Next up, we have Mariam Shah. She's an undergraduate student majoring in chemical engineering and biomanufacturing at North Carolina State. And she received a NASA internship award to work with me actually at Glenn Research Center. So it's great to reunite here virtually. And then her research was focused on gauging capillary action and its application to some of the work we do at NASA Glenn. So Mariam, if you are all set, I can see your slides there and take it away.
Thank you so much. Hi, everyone. As Tyler just mentioned, my name is Mariam Shah, and in this presentation, I'll just cover some of the work I did as an intern at NASA's Glenn Center last summer. So a quick overview about me first. I'm currently a senior in chemical engineering at NC State, and last summer I worked under Tyler Hatch and Nancy Hall, and my co-intern was Samantha Easton. So the main thing that we worked on over the course of the summer was the Capillary Outreach Challenge, and Capillary stands for Capillary Effects on Liquids Exploratory Research Experiments. And it's an educational program where students in grades 8 through 12 design their experiments to test capillary action in microgravity using GRC's drop tower. So students design their experiment in a 2D software program called LibreCAD. And GRC takes those proposals and laser cuts them out to be tested with. And the cutout experiment is then placed into this box as shown here on the right. And this video shows what occurs in the drop tower. So as you watch, you can see the fluid rise through the channels as it experiences microgravity. And this video is an example of what the students will receive back after the experiment is tested, and then they can use the video to analyze and draw conclusions. So the main work that came with Capillary was updating documents that are listed on the slide, because prior to last summer, the students used a software called DraftSide to do their designs, but unfortunately it was no longer in use, so everything had to be switched over to LibreCAD. So in doing this change, we had to update the original template, the tutorial, the handbook, the flyer, and the website. The main document that we worked on last summer was the tutorial, and this document was written to guide students through the creation of a sample experiment in order them to teach them how to use the software. And the sample experiment created in the tutorial is shown here on the right, with this experiment investigating the effects of the curved channels versus the sharp angle channels. So after we completed this, we actually sent this out to the tutorial out to two high school interns who worked with Nancy Hall, and these interns went through the tutorial and gave us feedback on passages that were unclear and confusing. And the main thing that we learned is that LibreCAD works differently on a Mac versus a Windows, so we went back and added that information into the tutorial for Mac users. The other document that we worked on was the handbook for the students, and this covered the overall rules and design constraints for the competition. And the main thing that we did here was we added in LibreCAD information. We added in a tutorial for ImageJ, which is the software used to analyze the video. And we changed a little bit of the logistical stuff about the competition in the handbook as well. And then after we were done updating the various documents associated with Capillary, we moved on to compiling all of this information into the new and updated website. And we did this working alongside Glenn's IT Center. And I also participated in GRC's collegiate competition last summer, where the objective was to design a washing machine for the International Space Station, because astronauts do not have a way to wash their clothes. And NASA had a general layout for the washing machine, but my team and I worked specifically on the dirty water removal step that's circled here. So the objective here was to remove as much water as possible without damaging the fabric of the t-shirt once it had been washed. And we based our design off of a roller that's used in finished fabric manufacturing. And this process uses vacuum extraction to remove water. So the vacuum is usually applied through a rotating perforated drum that sandwiches the cloth. And our design was quite similar, as shown here, where the fabric is pulled through this claw-like mechanism and is passed through a perforated roller with capillary tubes inside of it. And all of the tubes will be attached to this pump line in the middle, pumping the liquid out of the washer to the normal water recovery system. The pump line will be covered in magnets, and there will be magnets inside the claw-like mechanism as well. So this will apply pressure to ensure that majority of the water that can be suctioned out will be. And the red boxes here represent just process controllers. And so in summary, a lot of my internship experience was gaining a lot of knowledge about fluid dynamics and microgravity, thanks to our work with Celery and the International Washing Machine Challenge, and that wraps up my presentation. So thank you so much for listening.
Great, thank you, Mariam. And just to add to it a little bit, so the Celery Challenge is pretty useful to us as NASA engineers because it kind of can simulate any type of disruption in a pipe or a flow line, such as a valve or a faucet, things like that. And then part of the challenge was for the high school students to go and measure the fluid velocity as it traveled along whatever design they made. So Miriam, could you talk a little bit about the tracking? I think you had a note about image J on there as well. What did you work on with that exactly?
So as I mentioned, the image J is used to analyze the video that GRC gives the students. And from what I understand is that they can click on the meniscus of the fluid as it's traveling up. And based on their design, so if it's curved versus sharp angle, they can see if curved angle helps better with capillary action compared to sharp angle curves.
Yeah, definitely. Great. And there is one question in here I see. It sounds like you did quite a bit of work with students as well as your NASA colleagues. So what was it like to work with the high school students in developing some of the documentation?
Yeah, so the high school students helped with the tutorial, and it was wonderful because they were able to provide a fresh perspective because the competition is geared towards their age group. So we could see what challenges that they had with the tutorial and what questions they had regarding the competition, and use that to build the FAQ and the resources section of the website as well.
Okay, great. I do see one question in there. I'll probably have to save that for the end, Mariam. So just as a heads up, but thank you again for your presentation. Great job.